Okay, hi. This is me again. Okay, now I'm going to go through some of the interesting questions that you might see this in IB exam. Okay, so let's read the questions. Okay, you have 10 cm cube of hydrocarbon. In this case, the formula of hydrocarbon is not given, and the question did mention that it is in the form of CxHy. That means that x and y are both unknown, and you're supposed to solve based on the information given by the questions. K is measured by certain temperature, SATP. So 10 cm cube was reacted, okay, with 70 cm cube of oxygen. However, this question is not that very clear. I believe that the 10 cm cube is fully reacted in this case. If not, the questions cannot be solved. So the 10 cm cube of hydrocarbon fully reacted with 70 cm cube of oxygen. Take note that the oxygen in this case fully reacted also. So there's no remaining oxygen. As you can see from the data given, the resulting mixture collected was found to have a volume of 60 cm cube and is completely absorbed by potassium hydroxide. So there's so many data hidden inside here. As you can see that if you use the word completely absorbed by KOH, that basically means that the remaining gases that produce at the end of the day should not have any remaining oxygen. And that would mean that the oxygen used, 70 cm cube, are all fully reacted. Okay. We'll totally ignore the presence of H2O because, as you can see in the SATP, water is in a liquid form, so water is ignored in this case. So obviously the 60 cm cube, which is fully reacted or absorbed by KOH, will surely be the volume of carbon dioxide. So to solve this kind of questions, it is very, very, very important to know how to balance these chemical equations. So probably this question came out in IB in 2009 to 2012 one time, and then after that it disappeared forever. So to balance this equation, I think you need to know how to write the combustions of hydrocarbon, and obviously you know that the product of combustions of hydrocarbon is obviously carbon dioxide and water. Knowing that there's an X here, that means there's an X number of moles of carbon that produces X number of moles of carbon dioxide. And of course, if you have HY, which is Y mole of H, hydrogen, knowing that the formula of water has two H's inside, that means that the coefficient here will be Y over 2. Don't believe you just take Y over 2 times H2, you get back your HY, right? So that's how you get your amount of water produced. Once you're able to work out the amount of carbon dioxide and water produced, you're able to work backwards and find what is the amount of oxygen used. As you can see, right, this is X number of moles of oxygen, and this part is difficult. As you can see, you only have Y over 2O. In order to get Y over 2O, right, you need to use Y over 4. And of course, you know why, because if you take Y over 4, multiply by O2, there's a 2 there, it actually becomes Y over 2O. So that will be the balance equations between your CxHy and oxygen, which produces carbon dioxide and water. Okay? Once you have this balance equation, for me, the way I teach, right, is I always tell my students, you must be able to get the three very important data. What are the three very important data? That is the volume of hydrocarbon used, the exact volume of oxygen used, and the last one is the carbon dioxide produced. The carbon dioxide produced in this chemical equation. Okay, so as you can see, I already sieve out the data, and that basically is 10 cm cube, 70 cm cube of oxygen, and 60 cm cube of carbon dioxide produced. Okay, once you got this, I think it's very important to understand the concept that is I can always compare the mole ratio against the volume ratio. Imagine if I compare the mole ratio X over 1, and obviously it is equals to 60 over 10, that basically means that I'm able to work out my X, which is X equals to 6. Okay? And likewise, if I were to do the same for this one, which is the volume of oxygen, 70 over 10, okay, which is the volume ratio of oxygen against your hydrocarbon, and I compare against the mole ratio, which is X plus Y over 4 over 1. I substitute the x in because I already solved my x as 6. I'm able to solve my y now, which my y will be 4. So the formula of the hydrocarbon will now become C6H4. It's actually pretty easy if you were to understand the concept behind. That means you're able to know where to take the 3 important data, which is the volume of hydrocarbon, the volume of oxygen, and the volume of carbon dioxide. And obviously, you need to know how to balance this equation. Either you balance it on the spot or you memorize this equation. Okay? Let's look at the second question, which is slightly harder. Okay, more information. Typically a A-level question. Good standard. Okay. No matter how difficult this question is, again, you need to balance this chemical equation. It's the same equation that we have already balanced. It's CxHy. And obviously, like what I keep telling you, there are 3 very important data to collect from this question. Okay, so you can see in this question, right? I'm going to like do something. Yes. You can see the 10 cm cube of hydrocarbon is here. And then in this case, I have a lot of information. I have 70 cm cube of oxygen. Okay, they didn't say that this is the exact amount of carbon oxygen used. Okay, so now they tell you that there's a residual gaseous volume. Okay, so the residual gaseous volume is 55. So you must understand that the residual gaseous mixture, right, surely contains oxygen and carbon dioxide. I'm very sure that there will be no hydrocarbon left because it's fully reacted. And also there won't be any water because water is in a liquid form. So whatever residual gas you see, right, will definitely be carbon dioxide and oxygen remaining. So this 55, as you can see, right, was subjected to sodium hydroxide again, or aqueous alkaline, and it says that it decreased to 35. Decreased to, not decreased by, so be careful. Decreased to 35 basically means from 55 to 35, right, the change, which is 20 cm cube of this gas, must be carbon dioxide, because only acidic gas will be absorbed by your sodium hydroxide. Okay, got it? So once you know that this is the volume of carbon dioxide produced, and then you know that this is the original amount of oxygen used, and this is the remaining. So do you agree with my calculations here? That if I take 70 minus 35, that will be 35 cm cube of my oxygen consumed. And likewise, as I told you, right, you're able to capture this data by taking 55 minus 35, 30 cm cube of carbon dioxide produced. And obviously, this is the limiting reagent where 10 cm cube of hydrocarbon is used. When I got this 3 data, I can just substitute into the same ratio. Remember, I was telling you about the mole ratio, comparing the mole ratio and the volume ratio. Now I'm taking carbon dioxide, which is 20 over 10 equal to x over 1, right? And then I can solve my x, which is x equals to 2. And likewise, if I compare the mole ratio of O2 and hydrocarbon, which is x plus y over 4 over 1. And in this case, I know my carbon dioxide, oxygen is 35. And of course, hydrocarbon use is 10. I'm able to solve my y because knowing my x is 2. And then after this 3.5, I bring it over and I solve my y is 6. So that means my answer for the molecular formula will be C2H6. Okay, it's pretty easy. Okay, so this is a kind of questions that you can anticipate in IB exam. Okay, but of course, definitely IB will guide because if they do appear, that could be the second time that this question will be raised. Okay, now if you look at the third questions, typically out of IB range, IB don't really ask this question. This question came from JC, and obviously one of the school that I've encountered. This question is from Nanyang JC. Basically one of the hardest questions that you will see in their tutorial questions. Okay, pretty good. As you can see, again, you talk about the hydrocarbon exploded with an excess oxygen. Of course, you can see that the information is super limited. Basically, it means that you must have some acquisition of knowledge that certain things are produced and certain things are consumed. So that's why the question becomes so hard. Okay, so you have a first contractions at 35. That means contractions of 35 cm cube occur. Okay, and then after that, they say on treatment of the product with sodium hydroxide, there is a further contractions of 40 cm cube. Okay, there's so many contraction, macam like giving birth like that, like contraction. So what do you mean by all these different contractions? I think it's very important to understand the second contractions, then the first contractions. The second contractions came about when you react them with sodium hydroxide, and obviously you know why, right? Because the removal of the carbon dioxide by the sodium hydroxide creates the contractions. So basically, the second contraction tells you something very important. It basically tells you the volume of carbon dioxide, right? Then, very simple. This part, you can get. That means you already know you can solve your X because you can see that your X in this case will be 40/10, which happens to be 4. X is 4. Okay. The first contraction, which I didn't really go through, I went through second contraction first because it's easier to understand. The first contractions require you to think a bit. Okay, you need to understand what's going on in these chemical reactions. Got aeroplane fly past, so it's very noisy. Okay, so the first contractions, as you can see, right? Okay, I already did some working for you. The first contractions involve, okay, the loss of the volume of hydrocarbon and also the loss of oxygen consumed during the chemical reactions. Okay, so take note. Anything lost, contract. Make sense? Because you use them, right? Then gone, right? So contraction lah. Okay, but you must understand that at the same time, right, something got produced, or it produces your carbon dioxide. So the net contraction, right, must be volume of CxHy plus volume of oxygen. Okay, these two contract minus away the production of carbon dioxide. So that gives you your first contraction. It's like profit and loss, right? You lose something and you produce something, right? So there's a net loss. So the net loss in this case is something that they mentioned, 35. Okay, so the net loss is 35. Is it okay? Okay, so based on these first contractions, you are not aware of the volume of carbon dioxide produced. Am I right? However, we already worked out the second contraction already. The second contraction tells you that the volume of carbon dioxide is actually 40. Okay, and you know if this is 10, okay, and if this is 35, okay, and then this is your question mark. Are you able to solve? You're able to solve, right? Okay. Can see? You're able to solve your carbon dioxide. You're able to solve your volume of oxygen use. Okay, I'll do it slowly. Based on second contractions, you know that your volume of carbon dioxide is 40. Okay, so you substitute your 40 into your carbon dioxide here. And already know that the CxHy used is 10. However, we do not know the volume of oxygen used, but we know that the first net contraction is 35. That means that you're able to solve your O2. Okay, how to solve? Very easy, right? You just take 35 plus 40, okay, minus 10. Correct? So that will be your volume of O2 law. Okay, so that will be volume O2, which is 65 lah. Okay, 65. Okay, so that's how you get the volume of volume of oxygen. So once you have gotten the 3 volume, right? Right? Like what I told you, you have the volume of your carbon dioxide CxHy. X over 1 is equal to 40/10. You can solve your X. X is 4. Okay, and likewise, you have the other formula, which I told you, right, is X plus Y over 4/1 is equal to 65/10. Why 65? Because I already worked out the oxygen volume here. Why 10 is because that's the volume of hydrocarbon. Then I can solve my X and Y again. And in this case, if you substitute everything in, right, where X equals to 4, and then you can solve your Y is 10, and therefore your formula will be C4H10. So the answer in this case will be C4H10. Okay, so that's how you get your hydrocarbons formula by using all this data. So this is a very interesting question that make full use of how we can connect their volume ratio to their mole ratio. And obviously, it is very important to balance the equation CxHy. Okay, so that's all. Thank you. This is that chemistry guy. Okay, bye.